Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called copy list with random pointer. So in this problem we have been given the collection of nodes or one linked list, and this linked list, every node in this linked list contains additional pointer that's called random. So generally linked list, if we see, linked list is like this, right? So let's say I'm having one linked list that containing the three nodes, right? And these nodes are n1, n2, n2, n3, right? And they are connecting like each other, so this is called linked list, right? But in this problem we have been given another additional pointer that's called random. So let's say this is next, right? This is next, this is next, and their additional pointer that's called random, right? So this is random and it's everywhere, right? So this random is everywhere, and random means it can point to anywhere. It can point to the same node, it can have null, it can point to some other node, or it can point to some other memory location, right? Some other node, right? So that's what random means. So I just wanted to give an idea that this is how this linked list will look like. Another thing is we need to return a deep copy of the list. So if I read it correctly, this is the linked list is giving us that each node contains an additional random pointer which could point to any node in the list or null, right? So it can point to any node in the list, and we need to return a deep copy of the list. If we click this link, it will open the Wikipedia of the deep copy. So to solve this problem, uh, I would quickly go through what deep copy and what shallow copy means, so that will be sufficient to solve this problem and to get an idea what does it mean. But to go deeper, like how this deep copy works and how shallow copy work, I would go through other online documentation that is available. So but just to get a quick idea, let's say I'm having this object that's called a, and this a object is having some variable. Let's say it's having some member variable that's called a1 and a2, and this a object is stored. Let's say this is my memory, right? On my computer, this is my memory, and this memory is like just making some number, right? So in real they will not be x1 x2, but they will be some other number. This is just a making number. So if my memory, if a is getting stored here in this memory chunk, and if I'm making a copy, if I'm cloning it, and let's say I'm making it b, just renaming it as a b, and just copying these a1 a2 here as well, or I can rename these to some other variable. But basically what I did, I simply copy this a2 and just rename it to b. And if I'm just simply copying, if I'm not creating new object, it will be the shallow copy by default, and it will be pointing to the same memory location, right? What it means, if it is pointing to same memory location, if I'm updating anything here, it's going to reflect to this memory, and similarly it will be reflecting to this memory, this object itself, right? Because I'm updating this object, it means it's going to update the corresponding cloned object itself, right? So that's what shallow copy mean, right? I'm just copying pasting this object to another object. I'm not creating the brand new object by the new character. On the other hand, when I talk about the deep copy, let's say the same memory like x1, x2, x3, and I'm having this object that's called a, and if I copy means I am just creating the brand new object that's new b, something like that, right? So this object, if I am creating like with the help of new keyword, then it means I'm creating the brand new object. However, what I can do, let's say it is a1 and a2, I can use this data. Let's say I'm having b1 and b2, I can just use this data. Let's say it is 2, it is 3, I can have 2 and 3 here as well. But if there is any change in this object, then it's not going to reflect in this object because this is the deep copy. Deep copy means it's an independent object. So let's say, for example, it's getting stored, A is getting stored on x1 memory location, then B is it, it will be stored in either x2, or it can store some other different memory location like x3 as well, right? It does not matter, but it's not tied to the same memory location that A is already tied with, right? So the conceptually it's totally different, and the question is asking us to return a deep copy. So deep copy means we need to build a brand new object and we need to return it. Alright, so this is the part of the problem itself. Now just coming back to the solution part, how we are going to solve this problem. So for example, I have been given this node. Let's say it's having two nodes in this linked list, right? Just to simplify this problem. So this next is pointing to another node that's having different data, that's true, and it's having the random pointer as well. So random pointer can point to itself, or it can point to any other node itself in the linked list, right? It can point to here as well, right? So what I need to do, first of all, I need to create this one here. If I need to return the deep copy, and I need to uh, correctly set up this random pointer. So random pointer, if it is pointing to here itself, I need to put it here itself in this new object itself. Similarly, I need to build this node again here with the help of new. So I will just build this new, and then I will just build this node itself, and the random pointer, for example, if it is pointing to itself, then random pointer my random pointer in this newly built node itself, it should point to itself, right? And the next pointer, let's say if it is null here, then this should also be null, right? So what I'm doing here, I'm just copying the same data, but I'm creating the brand new object. So once I build these nodes 1 and 2, what I need to do, I need to connect these as well, right? So I need to connect 1 with 2, and similarly this random pointer, I just need to make sure whatever the random pointer value is here, it should be the exact same in this deep copy as well. So this is what I have to do. Now how we will do that, that's the approach that we need to think about. So one approach might be, and I would say that's super optimized, or like the great way to do that, not using any additional space or anything. Just get this list, get this node one by one, and just keep creating the new nodes, and then somehow connect those, right? But I mean, as the initial step, what we can think of, we can just use some kind of the additional storage. When I say the additional storage means we can just think of some data structure, and with the help of data structure, what we can do, we can just dump all these nodes to that data structure, and later on we can think of to connect those nodes, right? So these are the two steps we can just break down this problem. So let's start from the simple, and don't make it too much complicated. So even if it might the complex problem, larger problem, just try to modularize the problem in the small chunk. So this problem, let's think about the two steps. So number one step is just take all these nodes, right? Just create all these nodes with the help of new keyword, and just dump in the data structure, right? So now coming back to the data structure, what data structure would be we want to use to dump all these nodes, right? So there are a lot of data structures that we can use, but in this particular problem, uh, if we are going to store in the data structure, and we have to retrieve as well, why we want to retrieve. And so the follow-up question is, first of all, why we want the data structure, and what's the benefit we are getting here with the data structure. The benefit we are getting, let's say I'm having some data structure, and if I'm dumping all these nodes in the data structure in the table format, let's say this is my node, this is my node, and this is my node, right? Given node in the another table, in this column I can just create the brand new nodes, right? So this table looks like the hash table, and if we use the hash table data structure, or in Java we call it hash map, then basically our key might be this node that has been given node, and value might be the new node, brand new node that we will be creating. The reason we are taking this data structure is so that now we will know, okay, where is our value and what is our key. Key is already known, right? So key we already know because it has been given in the problem itself. So from the key we can reach out to this value, right? And from the key we are able to reach out the value, we can connect these nodes, right? And if we can connect these nodes, then we are done, right? We can connect these nodes with the next pointer, and similarly we can just so this is the next, and then similarly what we can do, we can just use the random pointer, whatever the random pointer value here itself, we can just use the random pointer here itself, right? So that's what we can do, right? So this particular key node will put keep the address of the its next node. Similarly this node will keep the address of the another next node. And if we know the next node, right, and if we know this is pointing to the next node, and we need to connect this node value node to the another value node. So when I say the value node, it means this is the cloned node, right? Cloned node is brand new node. So this is the deep copy node that I have created as part of the value in the hash map. So this value node, it will connect to the next never value node, and that's how we can just connect this with the help of given keys, right? So I hope it makes some sense. If not, if it is not making it's not making the whole sense, it's fine for now. We can think about the two steps, like just thinking of about this data structure, dump all these nodes, and then just worry about later then how we will connect, right, these nodes. So let's do this. Let's create couple of placeholders here, and then we can just come back again and we can think about like how to connect. So there are two steps as I mentioned. Step one is like dumping all the nodes to hash map, right? So when I say the all the nodes as key and value as new node, right? So new node is like this new node, right? Or cloned node, that's the right word to hash map. So this is step one. Step two is with the help of hash map connect the newly created nodes. That's it, and we are done. Step 3 might be I would say it's still step 2, not step 3 really. So step 2 is basically and return the head of node, right? That's it, head of cloned node, right? So if I return the head of cloned node, it will return the whole linked list, that's newly created linked list, right? So let's go ahead and do that. So map, and another point here, if you observe, I'm taking the node here as the key. Another option is here to take the value itself, the data. And the reason I'm not preferring the data here 1 and 2, this one can be duplicated in multiple nodes. It's just a value, right? It's not a pointer, or it's not a memory address, right? So rather I will just store the whole node as an object. When I say the whole node itself is an object, means I'm getting it the address itself, right? So in actual memory, every node will have the different address, right? So even if it is 1 and the neighbor node itself is 1, they will have the different address in the memory because they are the different separate objects, and they are connected with the help of this pointer, right? They are pointing to each other, not each other, but they are pointing to the next neighbor node, but in memory they are having the different address, and we want to use that address as a key to uniquely identify. We don't want some key that might be duplicate, right? And that's the reason I'm taking the node itself. So let's go ahead and create this. Let's say this is gas, right? We name it as gas. Oops. And new hash map. Alright, another thing is we don't want to change our head pointer, right? That's why I just took another temporary node that says called as current. Let's say this current is not equal to null. In that case, what we want to do, we want to dump all our these nodes in our cache, right? So let's go ahead and do that. So cache dot put current comma new node, and new node, this constructor has already been given to us, right? So let's go ahead and use this constructor current dot val comma current dot, if this constructor is not there, we can just create the new constructor, right? And this current dot random, so this constructor will make sure that it's assigning all these values to the newly created node. And let's go ahead and current equals to current dot next. Let's traverse this node, right? So this is step 1 and we are done, right? So step 2 basically just to connect. Step 1 we just dumped all these nodes in the hash map. Now the step 2, as I was mentioning, let's go ahead and clear this whiteboard, and let's try to visualize in the different section, right? So this is 1 and this is 2, let's say, and this is random, it's pointing to itself, and this is next, so next is pointing to the next node, and let's say this is null itself, this is random, and this is next is null itself, right? So this next is null because there is no subsequent node. And let's say if I choose a different color here, the red color, and this is my hash map, and I created 2 nodes here, so 1 and this is 2. Okay, so this is key and this is value. So let's go ahead and create, I already created here the new node, right? So this node is new node and this value is 1. Similarly, I created the new node here and I created I just assigned this value as 2. In fact, I assigned this next value as well, so 1 is pointing to 2, so I assigned this value as well, like the brand new dot next, basically I pointed to here, so this is also having the next, right? And this next is also pointing to, right now if I see, it is pointing to this node, right? Because this is pointing to here, so this value will also be pointing to the key but not the value. What I need to do, I need to point this new node to this new node with the next, right? Similarly, right now what it's doing, let's say if it is pointing, random is pointing to itself, right? 1 is pointing to itself and 2 is null. Then as per my current code, what 1 is doing, it's pointing to itself, means it's pointing to this key value, and then 2 is random pointer in 2 node, new node is having null, right? All right, so now let's connect these correctly. So what I will do, I will get this value with the help of key. So map dot get and key, right? Let's say 1. So this get value, get, and then using the key will give me the value. It will give me this new node, right? So with the help of get method, I can get the corresponding value, and then I can connect these values together. Similarly, with the get of this one, I will get this value, and that's how I will connect. Let's see. So this current has been null, so let's reinitialize this again so that we can reuse the same temporary variable, or we can create the new variable as well, but we can just reinitialize to the head just to reuse this variable. So current is not equal to null. Now what I was talking about, let's say this is cache dot get current, okay, dot next. So this dot current, what it's giving me, dot current, it's giving me this new node, right? And dot next means this next. Now what value I need to assign it here, right? So now I need to assign it here is I need to assign this next to this new node 2, right? That's what I need to assign. And how will I get this new node 2? With the help of this key, right? This key means 2. So what I will do, I will just get this key, And how will I get this key? I know only one. I don't know two at this point. And to know two is basically to get this next one next. So let's go ahead and do that, right? So do this gas dot get one dot next means current dot next, right? So current dot next means I am just accessing one dot next. One dot next means this key, and this get method is giving me this particular value, and that's what I am assigning here. One next one, I mean new node dot next is new node, and that's having the value 2, right? Deep copy of these nodes. Similarly, I can just do the random. So if assigning this next is clear, I think random is similar thing. Gas dot get and then current dot random. So let's understand this as well. Random, right? So whenever I am accessing this guy current, it's giving me this new node. So I got this new node, and dot random means it's this random new node random, right? And then I need to assign the dot random is whatever the random is assigned already with the key node, right? So that's why what I'm doing, this current, uh, right? So that current dot random, right? So current dot random or whatever the random value is already associated with key, I'm getting that. And whatever the for example, if it is null, right? So it is the same value null, it's going to assign to this value itself, right? So that's what it's going to do. And if it is pointing to itself, like let's say for example it is pointing to itself, right? So dot random, what it do, it will just again get this key, and then it will give this value, right? And this value will assign to itself the same new node, right? So I don't want to add lot of confusion. What I want to iterate here, if this next is clear, it's exactly the same way, right? So this random is nothing but it's just a pointer, it's just pointing to anywhere, right? So just try to think and just to make it clear that this next is clear, and the similar way you can think about the random, it's exact same, it's nothing different. And once we are able to assign these pointers correctly, then go ahead and move this pointer as well, so that we can iterate the whole list, right? And in the end, let's go ahead and return this gas dot get head, right? And what it's giving me, this head dot get head is giving me this new node 1. So this new node 1 is the head of the cloned linked list. Once I get this head, means it will just give me the whole linked list, the deep copy of the linked list, right? And if I color it differently, like blue color, this is my deep copy, and it can have any number of the nodes. Here for the simplicity I took only 2 nodes, but it can have n number of the nodes. So let's quickly go through the time complexity and space complexity. It's simply straightforward order of n, because that's what we are going to do. We are maintaining the whole list. Let's quickly check for the compilation errors. So current is already defined. Okay, so we don't need to define it again, we can reuse the same variable again. Let's see for the other compilation errors, and if there is not any, let's go ahead and submit, and let's see if it is going to work out. So looks like it's working as expected, right? So here, before just closing this video, just to reiterate, or the quick summary is, here this is the deep copy. First of all, we need to understand what deep copy means. It's nothing but it's just creating the new object with the help of the new keyword, so that we can make sure it's not pointing to the same memory. That's one part. Once we understand what deep copy means, I'm taking here the additional data structure, so it's helping us basically to connect these nodes, right? That's the only role of this data structure. If we don't take this, then it's we need to put another logic, and it's little bit more logical problem. Then we can do that, and that will be the great solution. But even before, this is the first step. So just take this data structure, just dump all these nodes, and then after dumping, basically just connect these nodes, right? And the way to connect these nodes is just map.getKey. This guy is giving me the corresponding value, and I need to connect my value in the map itself, right? And that's what I'm doing. So map.get1, it's giving me this corresponding value, and map.get2, here the get2 I'm getting with the map.get current.next, right? So current.next, because I only know current, right? So my current in this case it's 1, and dot next is 2, right? And I'm moving forward because this is the linked list, right? So I'm moving forward my pointer one by one. So now my current will point to 2, right? And the similarly the next node, if it is there in the linked list, how will I know 3? The only way to know is that the current dot next, and in this case current is 2, so I will do map dot current dot next, is that means 3, and this guy will give me the corresponding value. It's stored in the map, right? And that value I need for to make the connection. So if this concept is clear, I think everything is good. So this is the main logic. Basically dumping is easy, and then this connection is also, if we understand and by the diagram, if we are clear with this picture, then I think it should be good. Hopefully this was useful. Thanks a lot. Bye.